This is Professor Hill, and today I'd like to talk to you about mining in Arizona. It's very important in this state. In the last 2 years, 2022 and 2023, we were number one in the country for the production of non-fuel minerals, meaning nothing that had to do with creating energy, not coal, not oil, not gas, but things like silver and copper and halite and gypsum, all the very many non-fuel minerals that this country requires. We were number one in the country for producing them. Also, we produce 71% of the copper mined in the United States, and since copper is intricate to electronics, it's very important indeed. There's a lot of employment involved in mining, everything from scientists to truck drivers. Last year, the mining industry in Arizona employed approximately 48,000 workers, with 6,600 of those being geoscientists, and the average pay of everyone being approximately $81,000 a year, which is well above the average pay in the non-mining industry. Okay, so let's get on to the geology, the creation of copper deposits. I took this photo in the gift shop of ASARCO Mine, which has a tour of their copper mining operation in the eastern part of the state near Tucson. You see a piece of copper there, right, where it says Arizona Copper Number 1. And then you see off to the left there that little green rock. That green indicates copper. Copper, as you may or may not know, oxidizes to green in the atmosphere. Sometimes they put copper on the domes of buildings or churches, and it turns green over time. The Statue of Liberty is made of copper, and that's why it's green. All right, so geologically speaking, how do we get copper deposits? So let's start with a stock. A stock is a large body of magma, less than 40 square kilometers, I believe. Could be cubic kilometers. But it's a large body of magma. And it has an assortment of elements in the magma. As you may remember from the beginning of the semester, about 98% of all rocks and minerals are made from only 8 different elements. Copper is not one of them, but copper can be in there in trace amounts. But sometimes there's more than trace amounts, and sometimes it gets concentrated. It gets concentrated when the magma differentiates into different parts. How can that happen? Well, do you remember Bowen's reaction series? How certain elements, certain compounds crystallize out at higher temperatures, some at medium temperatures, and some at low temperatures. Now, when something crystallizes, when it goes from liquid to a solid, it usually becomes smaller and denser. So minerals that crystallize out early at the high temperatures will contract, get heavier, and sometimes they end up sinking down to the bottom of the magma chamber. This leads to differentiation within the magma, because whatever elements were in those crystals, they're being pulled out of the magma soup, essentially, and concentrating whatever minerals are left in the upper portion. So again, it's kind of density driven. Things crystallize out, and if they're denser, they sink to the bottom of the chamber, and it causes differentiation within the magma. Now, another thing that tends to be in magma in small percentages, usually less than a couple percent, is water. It's usually dissolved in there, and you don't notice it really until it gets close to the surface. As water gets closer and closer to the surface, the water in this magma starts to bubble out and steam, and it's released near the top, and it branches off, and it tends to crack the rocks. It causes these fractures in the rocks. As it's causing these fractures, the copper or the silver or the gold, but we're going to talk about copper for now, that may be getting concentrated at the top can leak out into these cracks, and as it cools down, it may fill them and form what we call veins. I don't know if you've ever heard of a copper vein or a silver vein or a gold vein. They're kind of the ultimate what prospectors are looking for. You know, basically they're the pure element. Later on, Mother Nature comes in, and as you see at the top of this slide, we've got a storm cloud, and you see blue arrows pointing down. That's supposed to represent rain water infiltrating into the ground. Water and oxygen are chemically reactive substances, very chemically reactive. We don't think much about them because they're part of our biology. They don't hurt us or change us, but they're very highly reactive substances. And as water and oxygen percolate through the ground, they come in contact with the various rocks and they chemically change them. They sometimes take things out, that's called leaching, and take those further down. They have what they call an enriched blanket there. That enriched blanket, we're assuming enriched in copper here, may have been leached from above because of chemical reactions that are started with the water and the oxygen. Anyway, these chemical reactions cause different types of copper deposits. You may remember when we were studying minerals that there are all kinds of classes of minerals. There are oxides and sulfides and carbonates and all that stuff. Basically, the chemistry is making them into all these different types of things. Now, so we've got these different kind of copper ores, and I have up there 1.6 to 5%. That, we were told when I took the tour at the ASARCO mine, is 1.6 is the minimum amount of copper they need to be able to economically mine an ore. If it's got 1.6% copper or above, and 5% is considered very rich, they can make money by mining it and smelting it. But if it's less than 1.6, you know, it isn't worth their time. So think of that, 1.6%. So out of every 100 pounds of rock, you get 1.6 pounds of copper. This is one of the different copper ores. It's called a skarn. It's what happens when copper is deposited in a limestone or a carbonate. So that'd be a carbonate copper ore. There's another one, chalcopyrite, the shiny stuff. You've seen that in your mineral kits, I believe. That is another copper ore. And then I've got a bunch more that were in the tour that we got to see. And again, these are blue and green colors, and so that tells us that these are higher grade ores. There's a lot more copper in here because that's just the color that it turns, especially when it's oxidized. So I'm assuming those are copper oxides. Smelting. The process of turning rock into copper they can use basically involves furnaces and melting and chemicals and all sorts of other things. I'm not really going to talk about them that much because, you know, this isn't that kind of class. But it kind of leads me to the next thing. There are environmental issues almost with all mining. And there's environmental damage usually done when mines are created. We have to weigh that against the fact that our current civilization depends heavily on mining. You know, look around you in the room you're in. Everything in the room you're in was either mined or grown. Now, when I'm looking around, the shirt I'm wearing is probably part cotton, maybe. And that may have been grown, and maybe my coffee mug, yep, because that's ceramic, that would have been, well, no, that wasn't grown, that was mined. Maybe the paper was grown, right, from trees, but almost everything else was mined. And the things we like best, our computers, our cars, our appliances, all sorts of stuff like that, are all come from mining. So it's a balancing act. We want to preserve the environment, and we want to have the things we want, right? And a lot of people that show up and protest when a new mine is going to open, they're called in the mining industry NIMBYs, because it stands for not in my backyard, because it tends to be people that live in the area where the mine's going to start. But they drive their cars there, right? You know, cars that are completely dependent on mining. Everything from the fuel that you put in them to the plastics inside. Anyway, we live in a civilization that depends on mining to continue. It depends on it. Now, if we want to mitigate the environmental impacts, that's great. But we do have to realize that mitigation costs money. It's always cheapest to not care. It's always cheapest to not care. You know, if you may have heard of things like acid runoff and things like that from mines. That's from very poor mining practices, from people who don't care. The more we ask them to care and to preserve the environment that they're in, the more our things are going to cost us. It's just a trade-off.